Hello, everyone. My name is Gong. I am assistant professor in the Department of Sport Management at Rice. Standing next to me is Sue. She is assistant professor in the Data to Knowledge Lab at Rice University. So today we will be presenting our paper entitled Estimating Positional Plus Minus in the NBA. Our talk will consist of 4 parts. First, we're going to talk about the motivation of our study. Then we're going to talk about the research question section of our paper. Third, we will share with you some details of our methodology. And last, we will recap the whole talk and briefly discuss some future research ideas. So let's start with the motivation. In the field of sport analytics, knowing how to objectively evaluate player performance is always a core question. And recently, plus-minus has become one of the most popular performance metrics in the NBA and in many other sports leagues. What you see on the screen right now are some notable examples of NBA plus-minus metrics. For example, in 2004, Rosenbaum developed something called adjust plus-minus. In 2010, CO created something called regularized adjust plus-minus. And later on, we have ESPN launched real plus-minus, and more recently, we have Snare created estimated plus-minus. Generally speaking, plus-minus measures players' contributions to teams' offense and or defense while they're on the field. So if we think players are helping teams, we should expect those kind of players will have higher plus-minus ratings than other players. So far, most plus-minus metrics focus on analyzing player efficiency for individual players, which is fundamentally important because in a lot of cases, people may ask questions like, who is the best player in the league? Who should be selected into the first team, second team? And the rankings from those plus-minus metrics can potentially help us answer those kind of questions. But very few consider plus-minus at a position level, which is something we try to address in our study. Understanding positional value in sports can be very important for a couple of reasons. First, we think that position values can be very useful in player evaluation. In a lot of cases, people want to know how this player has performed compared to peers. So in that case, we may potentially use positional values as replacement levels to better assess player performance. Second, we think that knowing positional value can help us compare those values across different positions. So we could know which position is more efficient or less efficient compared to others. Third, we think that knowing positional values can help us compare them over time. Maybe some positions, they have increased their efficiency or decreased their efficiency, and knowing this positional values can help us to answer this kind of questions. Now I want to talk about research question section of our paper. In our study, we try to ask this very broad question, what are the positional values in the NBA? So to answer this question, we think there may exist some challenges. So first, what are the actual player positions in the NBA? If we want to use positional values as replacement levels in player evaluation, we have to make sure that the players with the same position are doing similar things on the court, so we can give them some fair comparisons. But the traditional basketball player positions like shooting guard, point guard, don't do a very good job of that because the players with the same traditional basketball player positions can do completely different things on the court. That's why in our study, we decided to redefine some offensive position and defensive positions first. The second challenge will be how to best estimate position values. There are so many different statistics in basketball. Which one should we pick to quantify those positional values? In our study, we decided to use plus-minus because it takes the player's teammates and opponents' performance into account, and also the plus-minus model itself is quite flexible. So overall, what we try to do in our study is to estimate NBA positional values using this plus-minus framework and redefine player positions. Next, I want to talk about some details of our methodology. And under that, we have two sections. First, we're going to talk about the clustering models, which we use to redefine some player positions in our study. Then Sue will talk about the plus-minus model here. So to estimate positional plus-minus in NBA, we first redefine offensive position using play type data. The play type data essentially describe how players are using their possessions to score points in basketball games. So the data provider, Synergy Sports, defines 11 different play types, such as spot-up shootings and pick-and-roll ball handler. After we collect those play type data, we use K-means++ to cluster players into 7 offensive positions based on their play type data. And the inputs of the models will be standardized frequencies of players' play types. Now I want to show you some clustering results here. The table here shows the centroid of redefined offensive positions. In this table, each row represents one offensive position we redefined earlier, and it also shows the central frequencies of play types for that particular position. So for example, the first position we defined called roll and cut big. And for this position, players on average spend about 24% of their possessions on the cut action and about 22% of their possessions on the pick and roll man action. The rest of the offensive position we define in our study includes post-up big, skilled big, movement shooter, spot-up shooter, versatile scorer, and pick-and-roll attacker. I also want to show you the relative share of those redefined offensive positions in our study in the NBA. The players you see at the end of the lines here are typical examples of those positions. For example, the relative share of post-up bigs has declined significantly over time, which is expected. And Joel Embiid was a very good example of post-up big. The relative share of spot-up shooters has increased significantly over time, and Robert Covington is a very good example of this position. Next, we redefine 3 defensive positions based on players' official positions. So the table you see here maps NBA official positions to the 3 defensive positions we redefined in our study, which include big, forward, and guard. In summary, our study redefined 7 offensive positions based on play type data. We also redefined 3 defensive positions based on official player position data. Overall, each player in our study is associated with one offensive position and one defensive position, except for low usage players who are not associated with any player positions in our study. So next, we will have Sue to talk about the plus-minus model.
To estimate the positional plus-minus values, we employed a Bayesian regression model with hierarchical priors that reflects those 10 defined positions. We use NBA regular season stint data extracted from play-by-play data. A stint is defined by a unique matchup between 5 offensive and 5 defensive players. For each stint, we construct a response variable, which is the number of points scored normalized by 100 positions. We use total of 6 seasons of data from 2015 to 2022. Here's how we set up the plus-minus model. Suppose we have M total stints, N total players, and k total teams in one season of data. Here, y is a response vector, so each y value is the number of points per 100 position for that stint. X here is the design matrix for the players. So 1 is a player on the offensive team, -1 is a player on the defensive team, and 0 is a player not on the court. Therefore, X has a total of m rows, where each row is a stint that has exactly 5 ones and 5 -1s, and the rest are 0. And beta here are the coefficients for the player plus minus values. Each player has an offensive value and a defensive value, so we have a total of 2 times m betas. In a similar way, Z is the design matrix for the teams, and the gammas are the coefficients for the team plus minus values. Next, we define the hierarchical structure, which is the key innovation that allows us to estimate the positional values. For the coefficients beta, which are the player plus minus values, we group them by the 10 positions. So for the betas that belong to position J, we put a hierarchical prior, which is a normal distribution with mean mu J and variance tau J square. So 10 positions, 10 hierarchical priors. And the mu's are the key parameter of interest, which estimates the positional plus minus values, and they will be estimated from data. To complete the model, we need a top layer of hyperpriors, and in this case, we use non-informative priors for the mu J. And in addition, there are some beta that belong to low usage players without a position. We also put non-informative priors without the hierarchical structure. Due to the conjugate priors, posterior inference can be done using a standard Gibbs sampler, which iteratively sample all the model parameters from their posterior distributions. Besides the hierarchical structure, another advantage of using Bayesian model is that point estimates and uncertainty measures can be easily calculated from the posterior samples. For example, we can derive the credible intervals of the positional value difference between 2 positions, and those intervals have straightforward interpretation. Next, Hua will present the model results and conclusion.
So here we draw the posterior distributions for NBA positional offensive plus minus over time from 2016 to 2022. What you see on screen right now, the x-axis here represents the estimated plus minus, and the y here represents 7 offensive positions we defined earlier. So looking at this graph, one takeaway we learned is that we think the versatile score is the most efficient offensive position. This is because in this graph, it seems like the versatile score's offensive plus minus is higher than other positions' offensive plus minus. To test that, we can construct this 80% credible intervals of the differences of offensive plus minus between the versatile score and other positions. And as you can see here on the screen, most intervals here above 0, meaning that there is some evidence to say the versatile score's offensive plus minus is higher than other positions' offensive plus minus. Moving to the defensive side, here we draw the posterior distributions for NBA positional defensive plus minus. One takeaway from this graph is that we think the big is most efficient defensive position. This is because it seems like the big's defensive plus minus is higher than other positions' defensive plus minus in this graph. Again, to test that, we can construct this 80% credible intervals of the differences of defensive plus minus between big and other positions. As you can see here, all the intervals here above 0, meaning there is quite strong evidence to say the big's defensive plus minus is higher than other positions' defensive plus minus. Another takeaway from our analysis is that we think the gap between positional offensive plus minus has shortened over time except for versatile scores. So if we can take a look at this graph here again, the offensive plus minus graph, we will notice that the versatile scores offensive plus minus is consistently higher than other positions offensive plus minus in this graph. But if we pay attention to the positions at the bottom of this list, we will notice that those positions offensive plus minus are getting closer to each other over time. This is quite obvious in the bottom three plots, where those bottom positions offensive plus minus are getting really, really close to each other. We think that the rise of row and cut bigs offensive plus minus may contribute to the shortened gap. So here we can draw the same offensive plus minus plot, but by offensive position. It becomes quite clear in the first graph that the row and cut bigs offensive plus minus has increased dramatically from 2016 to 2022 compared to other positions in this graph. So last, I wanted to recap our talk and briefly talk about some future research ideas here. In our study, we redefined some offensive and defensive positions in basketball. We also estimated NBA positional values using the plus-minus framework and redefined player positions. Our analysis is outcome-based analysis, meaning we draw conclusions based on the outcomes we observe in NBA games. Future studies may conduct more, I think, process-based analysis, meaning they can ask a lot of why questions. For example, they could ask, why did a row and a cut bigs become more efficient on offense over time? Is it due to coaching staff knowing how to better use this kind of players? Is it due to training? Or is it due to influx of talent big players? I think there are a lot of studies can be done in the future to answer those very important questions. So this will conclude our presentation. Thank you very much.
Great, thanks very much. Really nice work. My first question is, so there have been a number of studies that have done these different kinds of clustering for types of basketball players. And the ones I've read seem to converge on something like 10 to 12 clusters. I like 7 better because it's a smaller number. How did you guys decide on 7 for that?
Sure. We look at a couple factors. First, we look at this elbow plot from the K-means plus. So this is one factor we're looking at, how different number of clusters reduce the errors. And also we're looking at whether we have enough number of players under each number of clusters. We find out when we have 7 clusters and combined with this graph, we think the 7 is probably an optimal number of clusters. But it's not 100% sure we can use 8 or 6. But because of the factors I just mentioned, we think the 7 is probably the best number for us to use in our study.
Great. And then, so when I now think about an individual plus minus, should I be normalizing that plus minus by their positional plus minus to really understand their added value to the team?
Yeah, I think you can do that. One thing I would mention is when we estimate individual players plus minus, if we consider the player position as part of their estimation results, I think potentially can give us better, more accurate estimation results because you take the position factor into consideration. It is one very important factor to think about when we consider players' efficiency on the court. So definitely, I think yes.
And my last question is, how far back does your data go? Because it's pretty well known that the game of basketball changed before 2016, right? And so I think the valuation of bigs would be very different if you were looking in the 90s or the early 2000s. So how far back can you get the data?
Yeah, so we can only use the 2015. So the earliest data set we have is the 2015-2016 season because the play type data provided by the NBA.com, they only give us, the earliest data set is 2015-2016.
Yeah.
So if we could have more data about the play type data, we could have do similar studies to those early data set. Thanks.
Great stuff. And I was going to ask why 7, so I think we covered that. But it's interesting. Did you think about changing those 7s or redefining them over time? Like, is there any value, again, to seeing like how these positions changed and evolved over time? Maybe, I don't know if there's enough data here to do that, but it could be interesting because it could suggest also where things are going in the future. Maybe a valuable position hasn't yet really been defined.
Yeah, so I think one surprising findings from our studies, we thought the big players are getting better over time, but we don't know actually which one. So from our study, we clearly shows the row and cut bigs, those type of players are getting much better over time from 2016 to 2022. I think this is one of the biggest contributions of our study. We're really showing what exactly type of players is getting better over time. But we don't know why. Maybe coaching staff can tell us better why they're getting better over time.
And another thing that I was looking at these charts and the ones, I think the next chart as well, did you do any insights emerge from looking at the distribution itself and maybe the variance that each of these positions and kind of results in?
Yeah.
Because they seem, on one hand, very similar, but on the other hand, it seems like there's a rich kind of set of information there.
Sure. We also look at, in our full paper, we're actually looking at the variance of those estimated position, offensive plus minus and defensive plus minus. And there's a lot of information we can learn from those variance of positional values, but we don't have enough time to cover in today's.
So the tails might have some interesting observations.
There are many, many interesting findings from those variance estimations.
Were your cluster sizes all the same? Or were there different numbers of players in each cluster?
There are different numbers of players in each cluster.
It would be really interesting to see like which clusters are like the most scarce or the most rare, and see if that correlated with their overall performance as a group.
Yeah, I think that's a very good point, because when we showed the relative share in our slides, we try to show that.
Quite a bit back.
Yeah, but the one thing we worried about before was that the roll and cut bigs, why they increase so much, we worry it's because there is a lower number of those roll and cut bigs in the league. But it's actually there, if you're looking at the roll and cut big, the relative share of those positions is quite stable over time. So, we don't know why that happened.
Okay. One thing I would have liked to see in papers like this is a set of player rankings, player values.
Yeah.
And like a leaderboard, because that can give a reader a lot of confidence in whether or not your model's working.
Yeah.
If LeBron James is ranked towards the bottom, then we know something might be up. So. And so it's very difficult from, like, say, performance metrics of a model like this to really know whether the model's working well or not. And the other thing, after watching your presentation, would like to see is more player examples, just like this. Sure. But like that way we can see, oh, this is that group, but it's this prototype or archetype. Yeah.
Definitely, we will include that in our final papers.
Thank you.
Thanks.
I'm sorry we're all focused so much on your positional groups, but I was as well, and all of our questions are. I'd like to compliment you on that. Your positional groups make perfect sense to me, and I also understand something. I'm afraid going on too long, but I understand something that I previously did not understand. I'm a huge Kansas basketball fan, Kansas University. A couple of years ago, we had the definitive post up big in Udoka Azubuike, and I had a huge debate with a friend of mine about where he was going to go in the NBA draft, and the friend was more right than I was, although I think I won the bet. But and it's exactly what you were saying, that the post up big does not have the value in the game that he did 10 years ago, and I was behind the curve.
Yeah.
So I appreciated that. I will second Bryant's comment that in the presentation I'd like to see more. For example, did you study the question of whether this correlates with studies, with salaries very much? But my general question, my large general question is where do we go with this? I mean, a huge variable in evaluating a study such as this is what is the potential future impact of it. And some studies are troubled by the fact that there's really nowhere you can go with it, and you don't learn anything from it, other than what the guy has to tell you. But you have the opposite problem, that there are so many ways in which you could develop this research further that it's a little overwhelming. So I wanted your input into where you would go in doing follow-up studies if you had another lifetime to put into this. Where would you push this research to go in the future?
I think the next direction, as we mentioned in our presentation, we actually want to see more causal effects. We want to see why the roll and the cut bigs become more efficient on offense over time. So if we could have more data about those players, we can potentially study why those players are becoming more valuable on offense over time. So like we mentioned in the presentation, a lot of things we're doing here are valuable, but they're outcome-based analysis. We just see what is happening on the field, on the court. But I think a deeper question could be why those things are happening. What is the mechanism behind those things? I think if we could have more data, we will definitely more than happy to study those questions.
So that answer would push your future studies in the direction of connecting it to scouting, as opposed to connecting it to what the players are paid. Is that accurate?
Yeah, that's fair comments, yeah.
Right. Thank you, sir.
So I'll add on to that. From the modeling perspective, I think immediate extension can be change the response variable to something like a winning probability instead of the actual points normalized by position. But the challenge is the winning probability is difficult to define and quantify in this case, so we're still working on that.